Hello, this is Dallin with Developer Insight, and today we're going to be going over the fifth section of the Elixir guide, covering the case, cond, if, and unless statements. To start off, we're going to open up the Elixir interactive console by using the IEX command. There we go. And the first keyword that we're going to work on is the case. Now, case allows us to perform pattern matching against values that we specify in a succinct way. It works like a big list of if statements, but the syntax is much easier to understand. In this example, we use the case keyword to begin the pattern matching, and follow it directly with what value we want to match it with. Then we use the do keyword to begin listing our options. The first option is the tuple 4, 5, 6, which will not match the input value 1, 2, 3, as the values within the tuple do not match. However, the second value, 1x3, will match because the 1 and 3 match, and the x is acting as a variable that will be bound to the incoming value, which in this case is 2. If x were an existing variable and we wanted to match against x's previous value, we would need to use the pin operator like we talked about in the last video of this series. So in this case, x was already assigned the value of 1, and we are pattern matching the value 10 against the pinned x value, which is 1. In the first match, since those are obviously not equivalent, the second match is the one that will be successful. An underscore being used as a condition matches all values. This is used as a default to accept anything else that was not previously matched. If we do not include an underscore default value, and there is no successful match, then an error is going to be thrown. As you can see in this example, we are matching with an OK atom, but the only available option to match against is an error atom, which is an equivalent. This therefore causes an error. When writing values to pattern match against, we can also add extra conditions to our value. This added condition, called a guard, will only allow that value to match when x is greater than 0, allowing us to be more specific when matching with variables. One thing recognized with guards is that they will not throw an exception when they have an error, but will instead just fail that matched value. The head function fails when a 1 is passed to it because it's not a list and does not have a head value. In this example, we cause the same error within the guard. However, since the error is in the guard, the error is simply ignored and the value is not successfully matched. This is something worth keeping in mind, as it can cause a difficult bug to find when the guard is actually erroring instead of just not matching the value successfully. This guard functionality can also be usefully utilized with anonymous functions, as we can include conditions on the parameters that are passed in and handle the values accordingly. This anonymous function is going to perform addition or multiplication based on whether the x value passed into the function is positive or not. So if we try passing in the positive number 1 first, we will get 4, as the 1 and 3 are added together. However, if we pass a negative 1 as the first parameter, we will get negative 3 because the values were multiplied. So the guard really allows us to be more explicit as to what we want to do within our function when specific values are passed in as parameters without having to put a bunch of if statements within the function. An important note about this, though, is that the number of expected parameters for each function clause needs to be the same. As you can see, we are trying to have our anonymous function take 2 different amounts of parameters, so we will get an arity error telling us that we need to stick with one number of expected parameters. The second keyword we're going to go over is the cond keyword, when we need to match against conditions. This works like else-if clauses in many languages, where we will be looking for the first value that isn't false. Each of the conditions that evaluate to false are ignored until a true value is found. In order to duplicate the functionality of the underscore default value we used before, we can just use the value true. The true value is matched no matter what. One thing to note is that cond considers any value besides nil and false to be true. The first condition resolves to a 1, which cond considers a true value because it is not nil or false. The final 2 keywords we will cover are if and unless. These are useful for if we only want to check one condition, just like if statements in many other languages. If the value given to if is true, which in this case it literally is true, then the code within will be executed. Unless is the exact opposite. If the value given to the unless is true, then it will not be executed. If statements also support an else block, so we can avoid having to type conditions twice. Since the nil value evaluated to false, the else condition was executed and the respective string was returned. One important part of if statements is their scoping rules. When a variable is declared or modified within an if statement, then the variable or changes won't persist outside of the if statement. In this example, we are attempting to modify the value of x, incrementing it by 1, but the changes are not persisted once the statement is over. If we do want to keep the changes from within our if statement, then we need to capture it by assigning the returned value to a variable. And as you can see, it is giving us a warning also, because inside that if statement, the x variable is unused that we just created by incrementing it. So it's warning us that if we want to use it, we need to do something different. In this example, we do the same thing, but we return the value from the if statement and assign it to our variable x. This causes the changed value to be persisted. That's all we'll cover in this one, so thank you for watching, and I look forward to seeing you in the next one.